Thanks everybody for coming out. I'm Nicole, president of the Interdisciplinary Research Honor Society. We have a couple members here. If you could all raise your hands and wave. So if after this event you're interested in learning more about us, just come and talk to any of these people. They're very friendly. The Honor Society pretty much just likes to promote and recognize interdisciplinary research that's going on campus. We just like to get people together, see what they're doing in other departments. Sometimes it can be pretty siloed, so we like to throw different events to figure out what people are doing when they're interdisciplinary and just what they're doing in general. And so one of the ways we do this is the Speaker Spotlight event, which we have on a monthly basis. We're excited that Dr. Finn actually could be here to talk to us today about his research. Thank you. And we also have another one in March. If you will make sure you sign in on that sign-in sheet before you leave, we can keep you posted about some of the events that we have coming up. Also, a really big one that we're all excited about is IDR Day. That's coming up April 17th on a Wednesday evening. And that's when we're going to induct some of our new members. And we just have a round table event. We're going to be working with some of the people from the American Cancer Society and just kind of brainstorm in small groups interdisciplinary solutions to some of the problems that they're having in the cancer field. So please come out, make sure you sign in, and again, if you have any questions or you're more interested in learning more about the group, please see any of us. Thanks.
So I'm Elizabeth, I'm the speaker chair. I've got all the emails now. And I'd just like to introduce Dr. Buchanan today. He was gracious enough to come and talk to us about his work with the LumenHaus, and he got his bachelor's and master's in Croatia at the University of Zagreb in electrical engineering, and then later came to University of Louisiana Lafayette and got a master's and a PhD in computer science, and then has been here at Virginia Tech since about 1990. So if everyone would give a warm welcome and round of applause. Thanks.
Good afternoon. Thank you for inviting me here. And what I try to do in my presentation is to give some, insight into the development and building LumenHaus interdisciplinary project, and also talk in more general terms about sustainability, which is very important topic these days, and more specifically how to promote sustainability in built environments by enabling users to make sustainable energy choices. Since I'm in computer science, obviously I'll be focusing more on computer science aspects, but I'm certainly going to try to talk about some of the interdisciplinary challenges and issues. So first of all, what is LumenHaus? Some of you may have seen it. It is just on the architecture building. If you go out from Price for Parking Garage, you go to the campus, what you see is the LumenHaus on the top of the hill. And this house was actually started sometime 2006, 2007, because there is a competition supported and organized by the Department of Energy, which is called Solar Decathlon, where teams from all over the country build solar houses with participate competition, and then they are judged based on 10 criteria, from communication to business model to energy consumptions to mechanical and overall architecture, of course. So as you can see, it's started as an interdisciplinary project because in order to prepare well for such a competition, you need to bring together people from different disciplines. It started with the core team was from college architecture because they had built such a house twice before, in 2002 and 2005, and then they invited people from college of engineering, electrical, mechanical, engineering, computer science, to name few, building construction, also from College of Business and several other departments all over the campus, in order to create a team that is capable actually to not only build a house, but also build a house that can conform to requirements of the competition and also take into account all different, sometimes very complex facilities in different disciplines. And I can say, I think that was a great learning experience because we all come to an interdisciplinary project with perception, hey, there is one way to do it, and it's my way, everyone else should learn from me. And soon enough you know that that's not that way, that even if you think that you're right, you're probably not, and even if you're right, you should probably be patient and listen to others and try to learn and make your good idea even better. So again, if you want to do an interdisciplinary project, I think willingness to listen and a lot of patience is a good starting point. So, what happened is that with the house, it took us roughly 2 or 3 years to build it. It participated in the solar decathlon in DC, and in that decathlon, I guess we didn't do as well as in Topor, still good, but not as well as in Topor. However, we took those lessons and we improved on the house. And in 2010, the house participated in the European Solar Decathlon that took place in Madrid, where the house won first place. So, if you want to learn more about the house, there is a website, of course, but the overall idea is to how we can provide a highly automated house with a lot of sensors, that has a sensor-rich space, that has a lot of also, not just sensor, but also actuators, in other words, ability to move or control something in the house. And then having such a very instrumented house with a very general structure and floor plan, how such house can be used in different contexts, as a classroom, as a meeting place, as a living place, because although the house was initially designed as 800 square foot, because there were the constraints of the competition, 800 square foot apartment for, let's say, a professional couple or couple without kids, just because of the size, it can certainly be used in many different situations or many different functions. So before I proceed, I would like to show you a fairly short couple of minutes video which shows the house and probably answer the question that some of you may already have: how did you transfer this house from Glasgow to BC and to Madrid? So this is the house in Washington, D.C. that was all. As you can see, the house is actually the unit that can be transported as a container, connected to wheels, and just deliver like a huge schedule to get to the Here are some of the functions of the house. We're able to finance the whole house. The general idea is actually finance the house with big door that can open, expose the house, and connect it to the exterior space, thus extend the practical area of the house. Always a very small space, it has separate cars, it used to be an office, you see the living room plus kitchen here with different configurations. And then behind, around the office bedroom. Small bathroom, there is an opening in the center of the room, as you can see more light inside. This is the control system. The control system used in the house was usually used for 20 or 50,000 square feet building that we had in the house. Okay, so now that you have seen a little bit about the house and how it moves, I would like to continue and talk a little bit more details about each of those aspects. And by all means, if you want to your question, please interrupt me, and we can. This is supposed to be a discussion rather than just continue the lecture. So, just in terms of travels, just to number a couple of places the house was. So this is in Mall, Times Square, New York, in January 2011. It was very cold. I still remember that we were at 2 a.m. At 2 a.m., arrived around 2 a.m. and actually we were preparing house before rush hour starts in the morning. I think in the upper right corner, I think it's in Chicago, Millennium Park, and the lower right, I think it's Plano, Illinois, Transfer House, which is one of the important architectural places. And actually, you can see this is actually the original inspiration for the house, and I think this is the actual position of the house. It was in the middle of Chicago. So, just to give also overall layout so that you get some perspective of what you can see in the movie. So this is the 800 square foot area. You have a main entrance here, bedroom, central area includes is actually bathroom, small office area, and living area plus kitchen. In addition to that, there are patios on the left, on both sides, so therefore, as you open the sliding doors here, 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 and here, you can actually practically triple the effective area of the house by being able to connect with that. In terms of controls that I have mentioned before, as you can see, we have probably something around 1,000 sensor points. So if you think about that in terms of what you have in your apartment or in your room, you maybe have one of the control points. Here we have 1,000 for fairly small space. We have a weather station. We have which is connected to that, and we have several other components, including, of course, the energy inverters, so how we can actually gather the solar energy and put it to use. In terms of energy itself, this is not a house that has batteries. This is a grid house. If you think about sustainability and how such house can be powered and store energy, if you have large batteries that are big enough to actually support the house activities, you'll end up with something that's very expensive, takes a lot of resources to produce, and it's very toxic. So ultimately, it's not sustainable. Instead, what we are doing these days, we are connecting house to grid. During the day, house produces extra energy and sends it to grid, and it sells it to the electric company. During night, there is no sun, there is no production, then it takes energy from the grid. So the way to look at that is that grid, electric grid serves as one big battery to which the house is then connected. So all these components here, again, serves some of them to connect to grid, some of them to regulate electricity distribution in the house, and some of them, especially this part, serve to control sensors, and therefore they will connect to grid. So, actually, let me just go back briefly. So you can see here in this part, obviously you need someone who knows what to do with electrical energy, electrical engineering, power engineering, what to do with the sensors reading, processing, of obviously computer science, someone who knows what to do about overall mechanical structure, how to deal with heating, air conditioning, and so on. So just in this small segment of the overall house functionality, you can see at least 3 or 4 disciplines, mostly engineering, but still different disciplines within engineering that needs to be brought together in order for this thing to work. In terms of interior, you've seen it in the movie, you need to design furniture because this furniture is actually designed in order to fit the overall concept of the house. If you look at the floor is actually concrete, made of concrete, like roughly 4 inches thick, maybe a little bit thicker than that. And that floor that provides a passive capacity, because when sun hits the floor, it is concrete, it heats up, it accumulates heat during night, you can then it releases the heat. You can use that as a way to control exchange of energy. If you look at the patio, the lower right picture, patio is made of a special wood that lasts maybe 100 years instead of regular 15, 20 years that you have the regular patio type of wood. So again, I have just briefly skimmed over the various concepts that we have again. Energy part, architecture part, interior design part, appliances part, overall economic and part. And of course, to put all those things, this technology together, what can you do? What we decided, okay, what would be a nice point that we can distinguish our house from all other houses that competing at that time. Keep in mind, it was around 2009. And what we decided that it would be nice to actually to bring together web and mobile technology to provide user capability to control the house and then provide information to user about what is going on in the house, and therefore, as the title says, to enable the user to make some sustainable decisions. So that means that what we have in this house is actually a test bed. The test bed we can use for various experiments on how to afford that sustainability, how to increase support for people to actually make sustainable decisions. Just give you a brief example. There is a proximity sensor and also presence sensor. So if the light is on and no one is moving, of course light goes on. That's something that you can already see in various places. But also, if in the morning you can program house, so therefore if the user wakes up, I'll keep talking about user because I'm a computer scientist, but really we talk about the inhabitants of the house. So when the inhabitant wakes up at 6 a.m., house can immediately slide those panels and let light in. It can turn on TV, it can turn on the lights, so therefore it provides the next level in terms of configurability, how you can actually allow user to, again, inhabitant to actually use the house without worrying about those low-level things. And in order to do so now, the next set of disciplines comes to play, because we then need to talk about, well, how do we interact with human-computer interaction? What are the social aspects of that interaction? How support not just individual, but also a small group or groups in general living in such house. So, another question, well, another point of view would be, which we sometimes heard, is, well, okay, that's all nice and fine. If you have a big house, you can play in that house, you can do all those kind of things, but why does it matter? Why does it matter if I reduce temperature for 2 degrees in the house automatically and still make use of comfortable? Well, here is why it's matter, because if you look at this slide, you can actually see that just electricity itself accounts for 40% of energy generation, and therefore using solar energy to reduce the electricity generation needs can certainly help to reduce coal burning or green CO2 production and so on. Furthermore, when you look about the energy used in the residential sector, which mostly comes to electrical energy and gas, 74% of that energy goes to heating, refrigerating, and lighting. Precisely the very same thing that in your everyday life we are always doing in our domestic environments. Turn on and off the heating, adjust the heating, turn on and off the light, adjust the light, put things in the fridge, take things out, etc. So, just reduction of the average temperature of the heater for 1 or 2 degrees can have significant impact on overall energy production and therefore significant impact on the overall production in the United States or in general. So therefore, there is a lot of space here to actually investigate innovative technologies, and that's something that is really an open area of research, and it will be open for quite some time. Another example, actually, that's always strikes me because again, as you told, I came from Europe and I had a different mindset, especially coming to Louisiana, where it can get really hot during summer, and they put air conditioning, I don't know, 70 degrees. It's something absurd. At least for me, I mean, sorry, let me just qualify that. I enjoyed Louisiana, so it's just no reflection of it. It was a cultural shock to me. And then in winter, it was basically like 30, 40 degrees, which was for me just nothing. But then they put heating at 75 and 80 degrees. So think about that. Same setup. You can like in the summer, they had to have it 70 degrees and lower. During winter, comfortable temperature is 75 or even more degrees. And you can explain the difference by, okay, the houses are not heated equally, there's some gradient, but it doesn't really explain it all. There is some psychological perspective that we think, well, just because it's cold outside, it has to be like really hot inside just to make us feel better. And this is the kind of the things that can be really interesting to sustainability research. How can we help user, I wouldn't say change behavior, but let's say improve behavior over time to realize, hey, what is going on, and then at least have, I don't know, 75 degrees more during summer and winter if possible. And that's, again, how helping users to make sustainable choices can help change such. Another thing that we can then look at domestic environment is that, again, if you're looking at our daily habits, we work everywhere. At least that's my problem. My behavior. I check my email at work. I check my email at home. I answer to see this question from home. So therefore, there is no really separation between what you do at work, what you do at home. In old days, we can call it good old days, you left your work at 5 p.m., you went home, and you were free, so to speak. You don't have to worry about those things. However, these days it's like 24/7. And what we also nice is we can try to have those built environments which will not only sustain energy consumption, but also sustain us as human beings and help us actually remove ourselves from everyday challenges. So therefore, another line of the research that we can have in terms of social studies and social sciences, how can we promote what we call heterogeneous home? This home that is not the same like our work, where we have different levels of involvement, and there are certain areas where we can really relax and forget about work. So again, keep in mind the title, sustainability, built environments, and helping user to make sustainable choices and decisions. In order to be able to do so, then we need to learn about the patterns of use. So that brings us to, okay, how now we can use LumenHaus. We can have really good recording of how is energy consumed, at what time of the day, how that relates with the outside temperature, because again, with the weather station as a part of the house, we can then correlate those parts and actually establish patterns of behavior, patterns of use, and try to see implication of those patterns of use and how they relate to the home activities. So again, here are some of the challenges or questions, or research questions, interdisciplinary research questions that we cannot address or solve, hopefully, not just as a computer scientist or as an architect to design that space, but as an interdisciplinary team of social scientists, engineers, architects, economists, or because it all has to do about the cost and what is an optimal decision, not only in terms of sustainability in the long term, short run, but also sustainability in the long run. Because one of the major impacts actually is that tension between what we have in sight as a short-term goal and what we perceive to be a good deal or good saving, and what are the real long-term effects of our actions and whether we gain or lose in the long run. So when you talk about sustainability, we really talk about long-term effect, not something that has maybe 3 months time horizon. So to put all those things together, so what we have, if you look at the overall control system as a representation of the LumenHaus, is well, we have architectural part, which is environment in which users are placed. We have then also on the right side control that can control various parts of the house. It also controls how is energy is used from the solar panels or from the grid. That architecture, that environments interacts with again, I use the word user anyway. Just so used to it. So with the user, and there is that interaction, not just interaction between with the computer, but interaction with the whole space. And that interaction creates a perception, like it's winter, 75 degrees, what I need, or it's summer, I need something that's cooler than 70 degrees, kind of perception, which then leads to the user decision, and which then manifested as a behavior or pattern of use, which then results in some action, in other words, that control the house. So it's again, what we are trying to do is to investigate all those corners, in other words, how we can check what are the behavior, what is the decision process, cognitive process related to that, how the user perceives environment, how we can define architecture and space for them, how we can improve and provide better control capabilities, what type of the sensor we can do there, what type of the setup we can have in the house to better understand the sensing and also to better support action. So, immediate step is, well, let's develop some applications. And then when you think about that, as again, going back to this diagram, so here we have some kind of interface between architecture and human, and in order to provide that interface, in lack of better thing, in other words, something that does not depend on different devices and interfaces, we can use some mobile devices on the computer, etc., to create applications that allow us to capture this process. So right now, if you look, home automation is really growing, and you can get various systems that allow you to control light, to provide heating, and AC control, and various other things. You can, from your smartphone, watch the webcam in your house and see what's going on. However, these are really nice features. This is something that needs to be done as a first step. But you can really think about that as a necessary infrastructure for the next step. What will be the next step? To try to think about not in terms of very specific action, but in terms of policy, in terms of the setup. What do I mean by that? Is that, well, let's say, let's start the economy. You know, we are, we don't have enough income this month or next month. What setup can we put in the house so that we can save as much energy, and therefore save as much money on energy costs as possible? That would be one setup. The other, and that means that it covers all set of activities related. How will we manage light? How will we manage heating? What will be the preferred or default setup for the heating and or cooling for that range? So another way to look at it in terms of policy as well. We are going to have a party tonight. That means that all. We forget about sustainability. Don't quote me that, but I guess economy is on anyway. And then we say, well, we need to make sure it's comfortable for everyone. We need to have enough light, and therefore we have that setup or policy for let's say a reception. Or you can have some changing events, such as, I don't know, more people living in the same place. Therefore, you need to somehow compromise and provide setup for all of them. So if you look at that, what would be cool application, Facebook, Google Maps, Twitter, etc. And we try some of them actually. LumenHaus has a Facebook account, it has YouTube channel, it has a Twitter account, but it didn't really work out well because one of the problems, but that's not the problem, just the way how it was because of the design and processing, because of the fact that house has that much, that we didn't have people actually living there constantly. And what we're doing right now is just a small digression. We are actually have dug up a geothermal loop, so therefore there is a geothermal energy connection, and also we are we are now in the process of building energy house. Once we do that, house will move actually from 16 feet towards the price for garage. And then once we have it in place, then we actually be able to do some more extensive studies with people who live in, but at least staying for extended period of time in the house. And then we can actually try to plug in Facebook, Twitter, all those nice things and try to connect the social context of our living with underlying, infrastructure and built environment in which we are living. And one early idea that we also have is that, well, perhaps we can use some of those 3D life applications such as Second Life or Google Earth. And what we can develop is we can develop a Second Life version of the solar house. So you can actually go into Second Life. There is Virginia Tech digital preserve, and you can navigate the house, go inside, see what's happening. We also have the capability, which is not known for obvious security reasons, that you can actually mimic a behavior of the real house in the Second Life house. In other words, what happened in the real world, someone opens the door, will show up in the Second Life, but also other way around. If you manipulate the house in Second Life, the same manipulation will take place in the real world. So this is an interesting way how to use, again, the house to kind of lure the difference between real and virtual world and try to explore the virtual side of it for some more sustainability studies. In order to do that, problems, what are the appropriate methods, how we can interact with that, what constraints we have these days with emerging technologies. For example, one of the things that's working right now is a Kinect. And also there are a host of other devices similar to Kinect, but much smaller and much more convenient for our needs, that we can use them to further instrument the house. And what it means is that if I'm in a certain area of the house and I move my hand like this, that will be gesture. The gesture is recognized by Kinect, and that will be used directly to open the panel. So now we can open the door without user interface, without actually physical touch with the door, just by doing the gesture. So one way there is that, well, how can we then develop what is actually holy grail of the human-computer interaction? How we can actually provide a disappearing user interface. Forget about computers, forget about looking at the screen all the time. Environment around our house, the environment we are living in, is actually a big user interface. So what I'll talk briefly in the next several slides is some of the research activities that some of my students are doing or did as a part of the house. So one way would be, okay, how we can use physical objects as input devices, in other words, to replace interaction with computers. So what I just talked about Kinect and using the body and gestures to control the house is something we started in 2005, 2006 using augmented reality and some props and tools that allow us to provide simple interaction classes. Another thing is the sensors fusion. In other words, can we put some sensors on the user so that we can see how user walks, try to have some biomedical sensors, so therefore we can go into health and behavioral health. In other words, how is user feeling at the given point in time? Is there any medical potential medical problems? That means that LumenHaus can be configured as as a place for people with disabilities or for people with serious health problem where they can live comfortably and can be monitored without problem. So again, here are some of the issues, how we put those things together, how we manage power, how we communicate the data, how we do the data, and so on. Another thing is that, well, if we are having a house like that, how can we integrate all type of input devices? In other words, can we use a game console controller to control the house? And we actually developed a framework. When I say we, I usually mean my students. So after the professor after 2010 did actually a presentation about that, how we can actually connect this stuff together and provide interoperability framework. Similarly here, Kim, Ji-Sun Kim, she's the one who actually is still working on this topic of integration. Another thing is social computing. In other words, how we can use the social technology. I mentioned at the very probably beginning, like 10, 15 minutes ago, about the tension between the short-term decision and long-term decision, and how they may or may not help our sustainability goals. So what we have done, is actually found an experiment from psychology that actually mimic this situation, which is called social trust. When you are having groups living together or using the same resource together, then the question is, as an individual, I'm going to consume that resource and then basically have a short-term gain, but in doing so, I'm going to destroy the resource altogether for everyone. Or am I going to use that resource in important fashion with other people, and therefore I be able to maintain that resource for years to come. For example, typical example is that, for example, using grazing land for let's say cows, whether or not if you have large, if you overuse it, then the grass will disappear and you have just bare land, and so on and so forth. So what we have done, we have actually replicated that experiment in the second life, and what we try to do is actually to see, well, how can we model some simple resource use and to game theory and to see whether, first of all, whether we can replicate the result of the original psychology experiment in 1974, which we did, and also what can we decide about the behavior of such group. And we were able to actually identify at least 5 different patterns of behavior that we can then use and to try to simulate a situation when we have several people in the same house, and how we can actually model some of their behavior and patterns of use. Another issue that shouldn't be neglected is certainly privacy, because what we have here before, by the way, the student who did it is Shaima Lazim. I think she was actually a member of her society just a couple of years ago. So we can also look at that from the privacy point of view. How do we live in the environment? In other words, what makes us react in certain ways? And what Peter Radich did, he actually conducted a survey of 100 Virginia Tech students to ask basic questions about home, about how they, what are their expectations of privacy in the home. And the reason why we did that is because we wanted to see how that can translate into our sustainability decision. So that was rather interesting because there were some interesting biases that were there, because I think it went that far that at least on the sample that we had, which is granted very limited because it's a certain age, around 20 years, Virginia Tech students, but it turns out that if female, participants on almost not all of them basically, it said that if they found someone in their bedroom, even if it is their father, they would feel more uncomfortable than have someone who is female that they don't know that's included in the bed. That was really striking finding. Again, it is roughly like 50, 50, so we can look about sample of 50 female students, but it's a rather interesting sample that you wouldn't expect at all. And the other idea is, okay, healthy living. How we can connect what we have done so far with medicine, with health providers, with caregivers, and also how we can enable users to be their own caregivers. So we can develop a couple of applications, and that was actually done as a part of the summer program for undergraduate students, a group of students from Oregon State. They actually developed a couple of applications, and they demonstrated feasibility that we can actually, again, use LumenHaus to provide users necessary information that will help them control health issues or challenges. And also, just to show you that it is not just about iPhone or particular interfaces, we actually explore all kinds of interfaces that we have. This is, for example, iPad interface that allow you to actually get a pretty good idea of what is the consumption. Long period of time, basically, this is over the year. And then you can compare it with more immediate consumption. It also allows you to control the panels, so therefore this slider basically, as you move them, the doors will open and close automatically. The latest research that we are having right now is actually how this concept that we learn about sustainable living can actually be used in actually for military applications, because they have big problems in terms of housing, and especially abroad, and how they can actually create and have built environments that are portable, that are as energy self-sufficient as possible. They provide a place where people can recover or rest from everyday fatigue and stress, and also that fit in the overall military constraints, in other words, that you can integrate it with command and control construction. So you can see what started as a basic solar house actually led in a wide array of possible research topics which are not directly related to. Okay, so what's next? I'm almost done, so basically the last couple of minutes, the last couple of slides. In terms of disciplinary stuff, we need to talk about social requirements. In other words, how we can explore the relationship between the change in behavior, change in system characteristics, how we can adjust system, and talk about system, talking about the overall house. And also try to see how to encourage the user to use the visual information that can be provided to them, and how to show that they actually trust the information, and also trust that they are going to respect their privacy and address their privacy concerns. So we can also talk about design of the social adaptive systems, provide scale it up. In other words, one of the next projects of this is that's led by College of Architecture is actually bringing the solar house up to the, let's say, whole block. And actually they have an ongoing project in Chicago, Southworks, where they're actually trying to design a modular building, maybe 6 to 10 floors, build up those modules such as LumenHaus and integrate them together to provide control for the overall. And if you think about that, we can also look at the Vision Campus, and we can learn from this experience and use it to apply to Vision Campus. And finally, overall interaction with not just with the designated computer application, but also with smartphones, iPads, or as I said early on, just with using human body as an interaction device. Okay, thank you very much. And if there are any questions, please. Yes, please.
So do you have any sensors that see how a person navigates through the house? I mean, you look at like energy use, temperatures, and all these patterns that are most connected to like the modern world, but sometimes do you also look how people navigate through the house and like how to interact with the more passive type of things?
Yeah, well, we have several sensors that can do that without cameras, because there are also some privacy issues. You know, if you have camera, think about it. I tend to forget that I'm actually not being recorded, but if you're aware that 24 hours a day you are recorded, you're going to change your behavior. So we have some other things such as proximity sensor or some pressure sensor that can actually tell us, not with such accuracy, but at least we can know which of those 4 main areas of the house our users are, and with the timestamp, so we can know as they move from bedroom to living room, how long they stay in the living room, and so on. To have more detailed stuff, what we are looking at is actually to try to get some use such an infrared camera or something that doesn't record real picture, just some kind of, I should put it, basic overlay or layout of the users, and then we can do it. The moment we move house to the fixed place, people start actually living, we are going to do research on this.
So what time period are you thinking about? people living in this house to put
Well,
in service?
here is the thing, with those houses, I guess one thing that I didn't say is that one of the great skills that you need for a project like this is being a very good supplicant or beggar, I guess. And because the house costs a lot, basically you're waiting for the company to do that energy power free of charge. And when they tell you that they are doing it for free, you wait when it's convenient for them. I would say we will hope to do it by end of this semester. But if you happen to have $100,000, you can do it now. But let's put it this way. Yes, please.
How do you expect the physical design of the house to change if you didn't have the restraint of being on a truck driving on the highway?
Good point. So the restriction actually of the size of 800 square feet was the overall restriction, and then we wanted to make house movable because this gave us some points. But it will still be modular house, but I think some of the things that we wouldn't do that way, certainly we would have a module with an option, with doors, and as I mentioned that research with Chicago and South works, it is exactly what you're just saying. Start with basic model and put it and actually call it, the architecture people, they have a name for that, the concept, they call it luminosity. That's how you can build from basic LumenHaus model and put it. Yes, please.
So what is the cost of this house?
Well, it's hard to say because there are a lot of free labor. You're a graduate student, so it's a miracle what you can have graduate students do for pizza and coke. Actually, I don't know if you remember that, I'm digressing, but I'm just saying, if you remember that panel, that kind of slide, the metal panel with openings, it was not then produced like that. It's actually laser cut, and then you get students spend a day or two actually manually twisting those circles to get. Anyway, so having said that, our best estimate is something around $300,000 for that customized business. But I think in this mass production, we should go well below $200,000.
And the question I had was like, the LumenHaus just had one bedroom.
Yes.
So if I was to buy a house here like in 10 years now, I would be like at least 2 bedrooms. So what would be the issue?
You can add another module on top of it on the side, and that's what luminosity is. However, I can tell you this because we are giving a lot of tours, and there is usually, the parents of Virginia Tech students, and they say, great, now that my kid is out of the house, we can buy this house and go somewhere else. That's their usual action. So there is a niche market for this type of a house. Yes, please.
So do you have, maybe I didn't catch this, but do you have different models or ways to be plastic in the design based on trying to market to different sectors or uses, and also making it still compatible with all those different smart technologies and sensors? Or are you kind of constrained on the setup?
Well, the answer is we are constrained on setup because we're constrained by the requirement when we started in 2006. However, we are planning, mostly it's college architecture, I think, and I just want to make sure it's clear that the lead on this project is from college architecture, so there is no misunderstanding. But we are planning on the next house, and that house will do exactly what you're saying, and therefore that's flexible in the sense that it can include new technologies without major reform or major redesign, and that's much more easier said than done. And how to do it, I don't know, but we will certainly try to make that next generation house as flexible as possible.
Have you thought about just using let's say, a room on campus to experiment with some of these technologies? Because there would be like a room that could have everyday use, like you have a classroom, you have a reception in it. Did you think about like having something that's more practical to the Virginia Tech community, or?
That's yes. I think that's certainly some idea that we had, but here's the problem. The problem is money. Okay. And the problem is the IRB. I mean, not that much, but whenever you're dealing with human subject, especially, we are not talking about an hour, demo or something like that. Things get really complicated, and for that reason, and as I said, money is another reason. We decided, let's have our house in place. At least we don't have to worry about that, and then we can use it as a testing. Yes.
So, with the energy usage for like all the sensors and all of that, I was just wondering, because the goal is to make the house more sustainable, but I was wondering kind of what the offset is between incorporating a lot more electronics and things like that into the house that are kind of continuously using. And then also, you were talking about the solar power,
Yes.
and I was wondering whether the solar power that it can connect during the day kind of offsets the part that's drawing from the grid at night.
Oh, yeah, and, well, again, we did test that, again, the house actually traveled to Madrid. That's a whole different story. If that was another 40 minutes lecture, how the house goes from Blacksburg to Madrid and back. But in the Madrid, it was like 100 degree Fahrenheit. And our house was the coolest house in both ways, in literal and other sense of the word. Because we have the pavilion principle, which means that we are heavily using passive approaches, concrete floor, breeze, because we have actually two sliding panels. I didn't mention that. One metal with those openings which allow the breeze to go through while protected from sun, and the other one is actually very thick, which is filled with space material, which is very light, bubbles filled with air, and it can actually provide R20 protection. So it can actually really vent the house during the day. Then during night it gets colder, you can close it, maintain the same temperature, and when the sun is right, like it was in Madrid, we were in class all the time. That was not an issue. Yes,
The
please.
question I had was related to the challenges of interdisciplinary research. So like, my question was what was the biggest fight you had back then?
Oh, where do I start? Well, I can tell you, it's at least in my experience, it was mostly that, and we tend to joke that it's a miracle that for 3 years someone got hurt in the process, but mostly was that tension between engineering and architectural side. Because we engineers, we are, also the obsessive compulsive disorder. There's a plan, a long plans. We do the plan, we do it, and then there's architect 5 minutes before the actual test and completion. Can we change this to look this way? Forget the fact that it takes 1,000 lines of code. Can we do it in 5 minutes? But although I was really, initially I was like really surprised with it, but I can also tell you that the ideas that architect can provide is something that engineer will never really think about that. So you really need to think about that as an opportunity, not as a problem. That's what it is.
One last question. Do you think like this interdisciplinary approach and like how to design a house is maybe also going to decrease building costs in the future? Because currently, my impression at least is that buildings always cost much more money than you think they do, like especially big buildings, because politicians, architects, they change things in the middle of the design or engineering or building process, and then
Not engineering, just architects. I agree. Engineers too, yes. Well, I don't know what would be the good answer to that. I think here is the problem, because while we have a large body of knowledge about how to design buildings, how to build buildings, how to use materials, we really do not know what does it mean when we add sustainability to it. And what we first need to do is to actually explore what sustainability principle is, what are the real long-term effects, and then perhaps we can be able. We still are going to build houses that go over price or over budget, but at least we'll build houses that can actually bring back some money down the road. So, if you are going for a home law builder who is going to give you exact estimate, forget about it. That's never going to happen. Yeah.
Well, it's about 1 o'clock, so everyone let's thank our speaker one more time.
Thank you.
And if you need some more food, go for it. And just remember Nicole's announcement of the IDR Day in a few weeks in April. You can go on our website, and there's all kinds of information there about
you can
joining.
register.
And membership applications still open.
Membership applications are due today,
Right.
so if you want to write a very brief essay, you get still turn it in.
Thank you, everyone.